Okay, so here it is. Here it is. I want you to find this. No calculator. Okay, so I love it. I'm hearing good thoughts. I heard somebody up here say it's in the first quadrant because it's positive. And whenever we have our inverse trig functions and the number is positive, that means we are going to be in quadrant 1. Just as a quick refresher, if the number had been negative, since it's a tangent, it would be in quadrant 4. Right? Sines and tangents are in 4, cosines, negative cosines are in 2. All right, so it is in, I heard someone say it is in quadrant 1. So there it is, in quadrant 1. What do I know about that triangle? Opposite is 5, adjacent is 2.
Find the hypotenuse, square root of 29.
Find the hypotenuse, complete your triangle, square root of 29.
And then you just hit the sign of that.
You want the sign of that picture. 5 over root 29, which is 5 root 29 over 29. All right, we blast from the past there. All right, 2 more. 2 more of these simplified things. So back to the notes. Keep that paper handy though. I think it's good to keep all those things organized. So you can pull them out and look at them when you're bored. In another class, not in this class. Okay. What do you want to do here?
Secant squared is 1 plus tan.
You change,
You are correct. So again, someone asked about this earlier. This is like proving in geometry. There are lots of different ways you can approach a problem, and you will eventually get to the end. The problem is, sometimes it takes you 40 steps, and sometimes it takes you 4. So we want to go with the 4, right? So I think you have a 40 idea, not a wrong idea, but it's going to take us down a path that's going to be tough to navigate.
so
Right.
first one is secant, is regular.
Instead,
Cos.
there's only 6 of them, keep guessing, eventually you'll get it.
CS.
It's cosecant. So this is cosecant squared. All right, I'm up for that. I can do that. This is a complex fraction because secant squared, besides being 1 plus tangent squared, it's also 1 over cosine squared, isn't it?
Yeah.
And what's tangent squared? Well, it's 1 over cotangent, but what else is it that might match what I got going on there? Sine squared over cosine squared. Remember, my goal is to simplify. So if I can get like terms, I can cancel. If I throw a cotangent into the mix here, while it wouldn't be wrong, it isn't going to help me. You see what I'm saying? All right, now what do I do with this?
You flip it and then.
That's 1 over cosine squared times cosine squared over sine squared.
And then you can cross off cosine.
So those are cross off. And this is 1 over sine squared. But wait, you just told me 1 over sine squared was cosecant squared. Plus this cosecant squared. So what is 1 cosecant squared plus another cosecant squared? Don't make it hard. 2 cosecant squared. Alright, so the first thing we did, this guy is obviously cosecant squared. So I left him alone. Came over here, changed secant into 1 over cosine, and tangent into sine over cosine, right? Then I have this big ugly fraction, so I inverted and multiplied by the reciprocal. That left me with 1 over sine squared, which is another cosecant squared that had to get added to the first cosecant squared to give me 2 cosecant squares.
So why can't we have done what Jake said in the beginning, because wouldn't that have been able to like cross out tan squared in the beginning, because it would have been 1 plus tan squared is equal to secant.
Okay, now you gotta be careful. If you have pluses and minuses in your problem, nothing cancels here. You can't cancel. You can't. As soon as you put a positive or a negative in, then no more canceling. It has to be all multiplied. Now, what you could do is split that up and make it 1 over tangent squared plus tangent squared over tangent squared. But now again, things are going down this loop-de-loo road that I have to navigate and hopefully eventually come out with what I want. Okay? So again, there is no single right answer. There are lots of ways to get where you're going. You just gotta get there. Okay? All right, last one. Any thoughts on this?
Equal to 0.
If that had been a plus sign in there, oh, never mind, it's not even squared, so never mind, no, that doesn't equal 0. What does cosine squared equal? Does cosine squared equal something?
1 over 1 plus cosine.
Well, it would be 1 over
Sine squared.
secant, or I mean, yeah, 1 over secant squared. But, yeah, remember Mr. Passwater's had to sine squared plus cosine squared is 1. So what is just cosine squared? What would that equal? 1 minus sine squared? Kids, it's just a little bit of baby arithmetic here. We're just gonna subtract that sine squared, right? So doesn't that say cosine squared equals 1 minus sine squared? You can write that down on your reference sheet if you want.
Wait, what made it positive?
Made what positive?
The sign.
No, this is the identity.
Identity. Oh, yeah.
That's the identity. Now I'm going to take this and plug it into my problem. So I'm gonna have sine minus 1 minus sine squared minus 1.
So like substitution.
Substitution, that's exactly what I mean. And why am I doing it? Because my job is to simplify. And if I have everything the same variable, sign, maybe it'll work out. I don't think this one's going to. I think I must have copied something wrong. But anyway, let's see what we've got. Sine minus 1 plus sine squared minus 1.
Yeah.
So putting in descending order, sine squared plus sine minus 2. That's it. Nothing else is gonna happen. That actually factors, but that won't help because it can't cancel. I think that was a bad problem. But anyhow, it's good that you know this right here. Cosine squared is 1 minus sine squared. That will become useful. What would sine squared be? Sine squared would be 1 minus cosine squared. we'll substitute those probably a lot. At the beginning of the period, for review, we solved a little trigonometric equation. You did a great job with it. Now you're gonna solve some bigger ones. But you're gonna do basically the same things you did before. So let's look at problem 3A. Try not to yawn, we're trying to stay awake and learn so that we all have good grades. Quarter ends in a couple weeks. All right, what are your thoughts? This is an equation, we're gonna solve it, what do you think? What?
No, divide by two. No.
What? Well, I can't really combine like terms because I don't have like terms, but I do have a common term, a GCF. What is my greatest common factor here between these two pieces? Cosine. So if I pull out a cosine, what will I have left?
Or 2 sine x.
2 sine x minus 1. Guys, when you factor out the whole thing, you have a 1, right? So when you distribute it back, see how that gives you your cosine? Think about a regular algebra problem. What do you do after you have factored? Like if we had x squared minus 2x, and you factored out an x, what would you do next?
X equals 2.
You set them equal to 0. So cosine x equals 0, and 2 sine x minus 1 equals 0. So we looked at our big equation, we noticed we had a common term, we factored it out, and then we set each factor equal to 0. Now let's look at that for a second. Where is the cosine 0? Cosine is which letter, x or y? X. Where is x 0? Right here and right here. So that part right there has 2 answers. The 2 answers are 90 and 270. That's where cosine is 0. Now, what does this one say? This one says, I want the sine to be 1/2. That's like your review question was. Where is the sign positive? Quadrant 1 and 2. Why is sine positive in 1 and 2? Because sine is y. And y is positive up. Now, opposite over hypotenuse is 1/2, which means that angle has to be how big? Across from the 1, and this is not root 2.
30.
That would have to be a 30, guys. When is it 45?
Root 2.
Root 2. Gotta have a root 2. So what are the answers? Remember, we already have these 2. Now we have this one, which is 30.
150.
And then we have that one, which is indeed 150. 4 answers.
Those are always gonna be 2 answers for
No.
each one.
No. It is a lot of the time, but not always. There's no really, I mean, some of them are gonna have no answers. Some of them will have 1, some of them will have 3. It just depends. It is common for them to have 4.
You don't have homework in class on Friday, right?
We'll have,
Yeah, no, I'm just making sure.
Well, you'll be watching a video of me standing here talking. You'll be taking notes
we love this class.
and preparing for whatever comes next after that. Okay, pre-cal subs for no one, including Shamar. All right, let's go. Let's get this one done. Here we
Do
go.
you pull the tan out?
Can you pull the tan out? So, you see what paying attention has done for Jake? He says, hey, this looks a lot like the one we just did. So I'm gonna try the same thing. I'm gonna pull out a tangent. What will I have left? Square root of 2 cosine minus 1 equals 0.
If we were to pull out the minus, would that change anything?
I would make this negative then. I would never do that. I would never do that because it's gonna make this one negative.
10x equals 0.
So then I'll set them equal to 0. So tangent equals 0. And root 2 cosine minus 1 equals 0. Which means cosine equals 1 over root 2. Or root 2 over 2.
So tan would be, is tan Y or X?
That means it's a 45.
Let's look at this, tan 0. Can't draw a triangle with a side of 0. So we're gonna look at our circle. Tangent is y over x. So where does it happen that if I put y over x, I get 0?
Oh, right.
Right here?
Yeah, right there.
What's 0 over 1, guys?
0.
0. Okay, so one of my answers is 0. Remember, that's 0. That's where we start. Does it happen anywhere else that if we put y over x, we get 0? Tyler's going like this. Does it happen over here? And that's 180. It does not happen here. What happens here? That's undefined. Right.
Like, can you explain how that's how the, like, why is the X is 0, but the Y's are undefined? Like, why is that? Like, why are they all undefined, or why are they all undefined?
Because 0 divided by 1 is 0.
What's 1 divided by 0?
Undefined.
Why wouldn't that be just be 0?
Try it on your calculator. You can't divide by 0. You
Okay,
can't
yeah,
have
that
1
makes
and
sense.
divide it into 0 pieces. Can't do it. All right, where is the cosine 1 over root 2? Well, let's start with which quadrants is it in?
1 and
1 and 4. Why is it in 1 and 4? Because cosine is x, and x is positive on the right. Now you've got a root 2.
45.
So your angle is 45.
45 and 3.
So pink is 45. But red, what will red be? 315. All right, probably one more here. Now, the only difference with problem 4 is we have changed to radians. That isn't going to change a thing about anything except how I write my answer. So when you look at problem 4A, what is your thought?
So get equal to 0,
Get it set equal to 0. I love that.
and then pull a tan out.
And then pull a tan out. Listen, Jake is on fire. So we will set it equal to 0. Is that all right with everybody? And then we'll pull out a tangent. And what will I have left?
You have sine squared.
Sine squared minus 1. So now I need to set them equal to 0. I never took attendance. So I have tan x equals 0, and sine squared minus 1 equals 0, which means sine squared equals 1, which means sine equals, what's the square root of 1? Plus or minus 1. Remember, when you take the square root, you have to put in the plus or minus. Get my circle back out here.
0 or 180.
I need the tangent to be 0.
Oh, pi or 2 pi.
Where is the tangent 0?
Well, it's isn't it?
Here
0.
and here? So you just did that. Right. You just did that.
0 pi.
So 0 and pi. Now before when we did it, we said 0 and 180, but the directions have changed. Now we're doing radians, so now it's 0 and pi. Now, where is the sign either positive 1 or negative 1?
Quadrant 1.
Now be careful.
1 and 2.
Okay, now, okay. I want you to stop and think about that. When you tell me to look at a quadrant, what you're telling me is that I would have a triangle where opposite over hypotenuse is 1. Can that be?
No.
Can you have opposite and hypotenuse match?
Oh.
So we're not a triangle, we're back on the circle.
Oh.
Where is sine 1?
Everywhere.
No,
Sine is x, right?
sine is y. This is why we struggle.
90.
Sine is y, or sine is 1 up here, isn't it? Isn't that where sine is 1?
Or pi divided by 2.
Pi divided by 2. And where is sine negative 1?
2 pi over 3.
3 pi over 2.
3 pi over 2. Are we okay?
Will you give us that cheat sheet with like the x over r or something like that? With the sine. Alright.
Okay. Now, I'm going to throw a curveball at you. Do you remember what extraneous roots are? What are extraneous roots? They're answers that you find and you do all right, but they just don't work. They're bad, right? Take out your calculator, put it into radians, and type tangent pi divided by 2. Error. Error. The tangent of pi over 2 is undefined. So therefore, look at your problem, guys. Can x be pi over 2? No, because when you try to check it, you're going to get undefined. So both of these answers are extraneous because they don't check in the problem.
So 0
Is there a way to check it without the calculator?
Yeah, you should know it's undefined here. 1 over 0 is undefined.
Oh, yeah.
I just wanted you to visualize it with your calculator. Yeah. Now, were you, I'd be on the verge of panic, because not only have I given you a bunch of just stuff, but now I'm telling you there could be extraneous roots. What you need to remember is the tangent is undefined two places. Straight up and straight down. If you are doing a problem that involves tangents, and you get a straight up or a straight down, throw it out. Sine and cosine are never undefined. So as long as your problem is all sines or all cosines, you're good. It's only tangent that's gonna cause you problems. And it's only gonna cause you problems if you are straight up or straight down. Okay?
That was a lot to take.
That's a lot.